Everyone, thank you for joining Vidcode's webinar that we're hosting today to talk about the computer science standards here in the US. And just to share a little bit with everyone about myself, I am a founder and CEO of Vidcode, and I had a really good time starting Vidcode. I actually had the opportunity to be a teaching assistant back in 2014 in the software engineering pilot program at the NYC DOE while I was finishing up my grad school degree in computer programming and art. So I was able and really privileged to sit in on some of the review sessions of the K12 CS Framework. And over the last 6 years at Vidcode, I've developed curriculum that's aligned to the standards, worked with our team of curriculum writers here, as well as, done a lot with the CSTA and the conferences and all that good stuff. So plenty to look at there. But, this is really a new topic for all of us. So I'm just excited to start the conversation here with everyone. And I know there's so much that we're all learning and growing each year in this space. So I wanted to start today by just talking about coding and computer science. And I know a lot of the times we talk about kind of the differences and the similarities with those. So coding or computer programming really means telling a computer what to do in a language it can understand. So JavaScript, Python, visual block programming with Scratch. Those are all those languages. I love to think of those languages like foreign languages when it comes to K12 education. And oftentimes I speak of JavaScript and Python as French and Spanish, as they're very related languages. And then computer science is the study of computation, and coding is a part of computer science. So there's so many kind of parts to this sentence, but we're going to be talking about all these concepts throughout the webinar today. All right. And so it's really exciting just to kind of look at the state of CS today, taking this data from code.org, and in the last 3 years, there's just been incredible growth, state by state, taking on the CS standards. So today in 2019, we have over 34 states who have taken on their own set of CS standards, which is really exciting. And with that, so now I want to take a dive. We're going to go through a couple of frameworks today: CSTA, K12 Framework, AP CSP. And I'm going to start with the K12 CS Framework. And so the K12 CS Framework, I mentioned it a little bit in my intro, but it was developed, let's see, I think it started to be developed back in 2015, 2016, if I'm correct. And it was released, it's fully fledged, everyone's out there using it. It's just an amazing framework for the state standards to use as a framework to develop their own standards. And the core concepts are computing systems, networks and the internet, data and analysis, algorithms and programming, a really big one, and impacts of computing. And I really love these core concepts. I'm someone who studied photography and then computer programming in grad school. And so I would say, just as someone who learned to program not that long ago, as a student myself, I kind of wish I had had these core concepts in my university program. I definitely got them out of the program, but going into the program, I didn't know that this is really kind of the core of the learning. And it's really neat too from a K-12 perspective, because you can see this throughout all grade levels and implement in so many creative ways. And how you implement the framework is really outlined in the core practices themselves. And so the K-12 core practices really encapsulate the common habits that students can form at every stage of their development as they learn CS. And really coming from the perspective that, K through 5, 6 through 8, every year they're going to learn these practices in a new way, not necessarily every year, but every couple of years as they revisit, which I think is really cool. And so the practices include inclusive culture, creating computational artifacts, which to us means programs, art projects, networks, maybe a hardware project, collaboration around computing. At Vidcode, we really see that as pair programming and learning, how to review each other's work, testing and refining. That also builds into that concept. Recognizing problems in a program, huge core skill, communicating about computing, and abstraction. And so looking at the themes of the framework, and these are broad themes throughout, a couple things that I know they were considering as they were built is, equity is huge, and this is something that has been addressed in all areas of the framework. Powerful ideas is something that is also a theme of the framework, and we really see this as, cross-disciplinary projects, real-world ideas. And I'll be sharing this slide deck with everyone after the presentation today. Computational thinking, we're going to talk about that in a couple different sections of today's presentation. And I really see computational thinking as breaking down the problem. The problems oftentimes in computer science, but it could also be in related fields. Breadth of application. So, and that's really focusing on the breadth of the applications of coding, all the way from, programming languages to hardware, to the impact of technology on all sectors, careers, and aspects of life. So, all right here. So to break down the idea of computational thinking even more, the frameworks really highlighted 5 ideas. Decomposition, which is breaking down a problem into smaller problems. That was kind of my top pick there. Generalization, which is comparing one problem to another problem. Abstraction, which is deciding which details don't matter. How can I make this program faster, simpler, easier for other people to understand? Pattern recognition, deciding which parts to repeat. And algorithm design, so solving all the problems of one type. All right. Now I'm going to quickly stop the share because I want to pause for questions. And I'm also going to share another poll with you guys. Let me see what I can do. I might actually only be able to do one. All right, so let me just switch gears. Back to the share page. Sorry guys, I'm struggling with my Zoom here for a second. Give me one moment, my apologies. Okay, so we're gonna dive into the CSTA standards. And these are really core standards at Vidcode when we're talking to schools and libraries and after school programs, common kind of core standards progression that many states and schools are using here. And with that in mind, so for instance, at Vidcode on our coding site, we, in every single one of our lesson plans, which we deliver via educator accounts, which everyone today can sign up for free and have access to these, we list the CSTA standards right there in the lesson plan. And we have over 200 plus lesson plans and individual online tutorials listing those core concepts. So that's how we integrate our CSTA standards. And let's go through the core components of these. So the first theme of CSTA is computing systems. And from a K12 perspective, students are going to progress from learning, basic troubleshooting in grades 3 through 5 to understanding how computer systems are built and function on a hardware level in grades 9 through 12, for example. And I'm not going to go through all the standards today. I will be sharing the slide deck and links, but just to pull out an example. So for example, as students are leaving middle school and entering high school, which is a time period we think about a lot here at Vidcode, students will, from a CSTA computing systems standards perspective, students will be leaving middle school with the ability to recommend improvements on interaction design or the design of a particular coding program or tutorial. So that's a really fun one to conquer and relatively easy to approach. They are also able to design projects for software and hardware in order to exchange data. I love this one because this is what I learned to do in grad school. You know, any simple Arduino project or makey. I know there's so many robots out there these days. Great example of that. And identify and fix problems with computing devices. So another option, another staple, but can be quite creative. I actually had a fun time even at a STEAM conference a while ago, breaking apart like a hair dryer, or how can you even look at a hair dryer like a computing device? It doesn't necessarily have to be a modern computing device. Okay, let's see here. And so networks and the internet is another focus of the core concept of the CSTA standards. And the way that the CSTA looks at that is one of them is cybersecurity. So from the basics, setting strong passwords to really being able to conceptualize possible attacks. And students learn about the physical infrastructure of the internet and how it works. I think this is such a cool category. Again, it's really easy to be creative with this. I've worked on a couple as a user experience designer on mobile security apps for companies like IBM, and this is what people are doing in the real world today. And so I think it's super cool that students are doing this. A couple suggestions here is take any app. You can go through, a mobile phone is a great example, and say, hey, where do you bring your phone? Where are you connected to wireless? Where are you connected to Bluetooth? What type of vulnerabilities does that build into your life? And I know this is a topic many schools have gotten creative with. And I hope that as a community, we can keep sharing ideas with each other. And so we wanted to share a sample lesson plan with you guys today. And so for the core concept of cybersecurity and networks, we chose a free curriculum that's offered by Mozilla. Definitely a big fan of Mozilla. And so you can see the link here. We'll share this as well. But this is one of our curriculum team's favorite lesson plans in this core concept area. So another core concept area of the CSTA standards is data and analysis. And it's, here, students start with the basics, like how do you organize files and create graphs in grade 3 through 5, which is so cool. And then grow into advanced interactive data visualizations, 9 through 12. On Vidcode, how we approach data viz, it's in more kind of our 40 to 50 of the Vidcode curriculum. We also, in many of the Girl Scout badges that we co-developed with Girl Scouts of USA for grades 6 through 12, there's the ability for students to create visual graphs with JavaScript of their own bio data or different themes of their choices. So that's just one example of millions to approach the set of standards, which is just so fun. I definitely feel like when I was learning a code, data viz, it's just like, it's such a great topic. You can find some open data sets online and really start with a lot of fun projects that way. And so today, wanted to present a simple lesson plan that you guys can leave today with. This one's on Vidcode. It's actually what I just mentioned, is the personal data graph. And on Vidcode, how we approach this is students are actually drawing the shapes of the graph, placing the data in space, and then doing some of the data analysis offline, bringing it into this front end programming environment. And so this is, I would say it's a perfect middle school project, but it really depends on, what coding programs your students have done before. But in general, if they've done Scratch or anything like that, then they can easily jump into this particular lesson. All right. Algorithms and programming, my favorite category, a huge category for the CSTA standards. In this category, students learn to code and write algorithms thoughtfully using best practices, and learn to get feedback and write software collaboratively. As I said at the beginning of the presentation, this is actually just a much kind of larger category, which is great. I think very much needed. For me, this is personally why I fell in love with programming as a profession. It's so collaborative. You get to talk. I thought it was really antisocial, but you actually get to talk to people and learn and iterate. So I felt, even though this is kind of the core technical processes, it's also one of the more, I find, creative areas. And so chock full, in the time of this presentation, I'm not going to be able to dive into too many more examples, but just wanted to, show a lay of the land here. And then again, give a lesson plan to correlate to this set of standards. And so the lesson plan we're presenting with you guys today for the algorithms core concept area of the CSTA standards is the Vidcode Hour of Code activity called Code the News. This is a fan favorite. It's been out there 3 years. We have a ton of school districts, schools who have introduced text programming with this particular lesson. It's really a good one. And so we'll be passing this to you guys as a great example of how to incorporate the algorithms core concepts. All right. And just a little more of an example here. I'm going to cruise through that. And finally, we've got the impacts of computing. There's so much discussion in this area right now in the news, so I'm sure much can be pulled from there. But culture, safety, social interactions. Personally, in the Vidcode curriculum, we build this in through all of our metaphors and discussions, and we have a lot of reading and reflection in our lesson plans. So we find that, it's really fun and easy and creative to incorporate this kind of throughout an entire curriculum. All right, so we've made it. We've got about 10 minutes left of the webinar, and I'm going to finish up with AP CSP, share some resources with you guys, and then definitely leave, hopefully, 5 minutes for questions. So please let me, or start thinking about anything I didn't cover. If I can't answer that question today, I'm going to share it with our team and make sure that we answer it to this mailing list or Eventbrite group as a whole. So with that in mind, here is the AP CSP standards, and I love the similarities throughout all three. We find with Vidcode that many parts of these standards apply to each other, which is great. So with the AP CSP, it starts with the computational thinking practices. So that is the 6 computational thinking practices represent important aspects of the work that computer scientists engage in, which is really neat. So 1 is connecting computing. The next is creating computational artifacts. 3 is abstraction. 4 is analyzing problems and artifacts, communicating and collaborating. And so the big ideas, and I love how the AP CSP curriculum is broken into big ideas. At Vidcode, we do have an AP CSP framework for our year-long high school courses. And it's really was actually fun to kind of reorganize our original curriculum into these ideas. So the first one is creativity. The next is abstraction, data and information, algorithms, programming, the internet, and global impact. And this particular curriculum has a big focus on group work, on top of getting all the K12 CS core curriculums really rinsed and repeated throughout the entire year-long curriculum. So with that, I'm just going to wrap up the informational part of each of these 3 set of standards. So to review, we did the K12 framework, we did CSTA, and we finished with the AP CSP concepts and frameworks. So there's a couple next steps that I want to talk about before we move into questions. And the first is I would love to invite everyone on the webinar to sign up as an educator on Vidcode. It's free. You have access to all the lesson plans that we shared today and more. And also just tons of tools to launch your classroom with unlimited students, and really integrate some of these lesson plans into your work. you can just head to the regular www.vidcode.com site, hit create account. You can sign in with your email, Google, or Microsoft Office login. After you sign in as an educator, create a class, and you'll be able to add students, access lesson plans, and start our Intro to JavaScript course.